Hello out there in remote learning land, and welcome back to the Earth Science Broadcast. Today's hot topic, we're talking about how do we define observation, inference, and classification. If you could turn those cameras on, of course with a big smile when we meet back to chat about this. And make sure to polish up and submit your GC assignments from last week. Get those in, folks. You don't want to lose that credit. All right. Let's get started. This first clip here, you have to use your powers of observation. Check it out.
How many passes does the team in white make? Go! The answer is 13. But did you see the moonwalking bear? Go!
Okay. Did you see the moonwalking bear, folks? The whole key there, if you're not looking for something specifically, we often don't notice it, but you have to be more observant than that. You have to observe the world around you to understand what's going on. And once you make those observations, well, then you can make inferences that hold weight, that actually mean something. You don't just, you don't stay in the basement and say, oh, I think it's going to rain for the next week. You have no idea what's going on in the basement, right? You have to make the weather observations, and then you can make an accurate prediction. Okay, so here we go. How do we differentiate between an observation and an inference? Well, take a look on the right here. You got two different sets of footprints coming together, and then some kind of mixing going on, and then, of course, only one walking away. Well, what would you observe? What would you infer? Hopefully you would observe, you'd say, oh, I observed two different types of footprints, so maybe those are two different species. The first one was an observation, the second an inference. Then you would say, oh, it looks like maybe they had a fight there, or maybe they had some kind of a party going on. That's an inference, right? We didn't see it. And then the walk away here, you might say, well, looks like only one left. Maybe the other one stayed, or maybe the other one got eaten, or maybe the other one flew away. Those are all inferences based on these observations. Okay, so an observation, information obtained directly from the senses, not just sight, right? A lot of us think just sight. Nope. What you smell, what you hear, what you touch, taste, those are all observations, right? You're observing your environment. Okay. Example, the rock is black and shiny, right? I can see that. I can see light reflecting. I can see the color. Another example, there are two different types of footprints, right? Right there, 1, 2, right? You observe that. The inference, however, is not just using the senses. It's taking the next step. It's interpreting the environment based upon what you observed. All right? And that's what's going on right there. What will happen in the future, right? An accurate forecast. Prediction that actually holds weight is all based on the quality of the observations you make. Okay? For example, here the rock formed 100 million years ago. Well, none of us were around 100 million years ago. How do you make a statement like that? It's got to be based on some kind of observations about that rock. Okay? Okay. The footprints were made by a dog. Would you say that's a good observation? Yeah, me neither. I don't know any dog that has feet that look like that. So if that's an inference you're making, you need to make more careful observations. Okay. So here you have it. Identify which one is an observation. Put an I there, or an O rather, and for an inference, put an I. So take a few minutes and see if you can fill those out correctly there. Okay. Counting 28 shells from the beach. If you're just counting them out, you're counting, you're just looking at things, you are clearly just making an observation. Okay. Damage from the incoming storm. Incoming storm is expected to be extensive. Well, that means the storm isn't there yet. So you're inferring that based on observations maybe someplace else, but it's not in Elmont yet. That's an inference. Hot and humid conditions will continue throughout the week. Well, we're not throughout the week yet. If you're saying throughout the week, you're making a prediction, right? You're inferring what the weather's going to be like based upon some kind of pattern of weather you're observing now. Again, that's an inference. The candle wax is melting. Well, if you look down here, you can see it dripping down. You can see it. Not inferring that. So that is simply an observation. Okay? The 7-day forecast here, right? How often is that accurate? Very rarely. But for a couple of days, it's usually pretty good. And then as you get further away, there are so many different variables in the atmosphere that the predictions lose their accuracy. The inferences lose their accuracy. And that's why toward the end of the week, you're talking 7 days away, they'll say, maybe a 25% chance of accuracy. Okay? Okay. How do we organize our work? Well, one of the cool charts in the reference tables is the HR diagram, right? The Hertzsprung-Russell diagram, and it organizes things that aren't even on Earth. It organizes the stars. And we do that because it makes them easier for us to study, to classify things, makes it easy for us to understand. Well, take a look at this chart. Here you have temperature on the bottom, and that goes from 3,000 to 40,000. You have luminosity, which means brightness, and that goes from negative numbers to positive. You get brighter as you go up. Over here, magnitude talks about size, right? And the further up you go, the bigger they get. So this helps us classify different stars, and stars have a lot of great names. One of my favorites is Betelgeuse. And Betelgeuse would be up here in the supergiant area, whereas our sun is simply right here. Okay? So there you have it. Get your definition down there for classification. Some examples, right? We classify things by color, size, shape, and texture. Stars, in this case, are grouped not only by color, but of course, as we said, by temperature and size. And incidentally, color and temperature go hand in hand with stars because the hotter they get, the bluer they get. Right? You've all heard of the rainbow, Roy G. Biv. Well, Roy G. Biv, red, orange, yellow, green, blue, violet. The hotter it gets, the bluer it gets. So temperature and color are definitely related there. Okay? Let's see if you can figure out a way to classify these items here. All right? Take a minute. See if you can put those items in the chart. How would you classify them? Take a minute. All right? Hopefully you looked at these things and you figured some way to separate them. Well, one way to do it, not the only way, but one way to do it would be to say, all right, well, what states of matter are they in? Well, water, gas, not gas as in evaporated, gasoline, alcohol, they're all in that liquidy state. And then for solid states, let's see, that would be ice as a solid, aluminum in its solid state, iron in its solid state. And then for the gases, well, oxygen in normal Earth conditions is a gas. Air, of course, is a gas. Water vapor is a gas. So maybe your chart looks something like this. But again, that's not the only way to do it. That's a logical way to do it. It sorts it out quite nicely, but certainly not the only way. Okay? Okay. So, short lesson today. We'll get to our summary lessons. These are always summary questions, excuse me. These are always Regents-style questions. And, they're usually multiple choice. And, of course, there's also part 2 questions where it's free response. But for the summary today, we'll use part 1 type questions. In order to make observations, an observer must always use, well, if you're observing the environment, you better use your senses, right? Got to use the senses, folks. Using a ruler to measure the length of a stick. So now I'm using, comparing to a standard, I'm using my sense of sight to see how long something is. And there it is. You're extending the sense of sight by using an instrument. An instrument is a device that enhances the senses, right? For example, a hearing aid helps you hear better. A pair of binoculars helps you see further. All right, it enhances the senses, so it's called an instrument. not to be confused with musical instrument. All right? The best example of an inference out of all of those, which one needs the extra step? Not just an observation, the extra step of inferring. Hopefully you went with the weather forecast for 3 days. Okay? Classification system based on the use of, well, which one of these makes sense here? If you're classifying things, we're putting things together based on something they have in common. So hopefully you went with right here, right? Similar characteristics is something they have in common. Okay? All right. Number 5, a student classifies several objects. The classification system should be based on, well, again, how do you put things in different groups? Hopefully based on what you're observing about them, right? If you're making a bead necklace, maybe you put all the blue beads here, the red beads here. When you get dressed in the morning, think about it. If all your clothing was in a big pile, it'd take you a long time to get dressed. And hopefully, if you're a little organized, you organize, you classify your closet. You put your socks in this drawer. You put your t-shirts over here. You got your pants over here. And you separate it all out so that you can get dressed much easier, right? Classification makes doing things much, much easier. Okay. Sum it up all together here. How do we differentiate between an observation and inference? Hopefully you can answer that on your own at this point. Make sure you mention the senses in there versus an educated guess. Why is a classification system important? All right, think about it. What does it help you do? All right. And, of course, for the bonus question here, which one is the following statement an observation or an inference? Rocks on the glacier are very shiny, and I see cracks forming in this glacier. So, of course, you've got to tell me which one that is. Is that an observation or an inference? All right, folks. Meet you back in the GC.